So on this sheet here, you're using D equals V times T from your purple sheet. Yes, I know it says change in, and average, but look, it's going to be distance equals velocity times time. Or you can use velocity equals distance over time, or you can use T equals D over V. Usually, I use this one and this one. And all you're asking is this possible? And then you're asking, is it reasonable? And I'm going to go really, really fast, and I'll show you how quick this can be done. So number one says, hey, is it possible for Miss Sarich to drive 225 kilometers at 90 kilometers per hour and arrive 2.5 hours later? You know what? I'm going to go 90 times 2.5. I went velocity or speed times time. And I got what as a distance? 225. How far did I say the distance was? So is this possible? Yeah. In fact, you know what, Tyra? If it had even been 230 to Whistler, I'd probably say, yeah, I probably could have done that. If it had been 300 kilometers to Whistler, I'd say, I don't think you can get there in 2.5 hours at 90 kilometers per hour. You sped. Okay. By the way, police are using this now with license plate scanners, especially in the U.S. They started saying, look, if there's no way you can go from point A to point B in that time, we're ticketing you, because in the U.S. they have those RFID on your windshield when you go through a toll booth, and that's how they charge you. If you get to the next toll booth too fast, they're going to ticket you. So drivers actually who are speeding will pull over, snooze for a while to increase time, and then keep driving. I kid you not. So I'm going to put P for possible. Is this reasonable? Is 90 kilometers per hour a reasonable road speed? Yeah. Yeah. Is 190 kilometers per hour a reasonable? So if they had said that, I'd be saying, no. Still possible mathematically, but not reasonable in the real world. Mr. Dueck drives at 80 kilometers per hour. He arrives at Kelowna. I'm going to again go distance times time, because that's the quickest way to get there. 350 times... Sorry, I'm going to go speed times time. 80 times 2. Is it possible for me to get 350 kilometers at 80 kilometers per hour in 2 hours? No. You know what? Since it's not possible, it's not reasonable. I'm not even going to go any further. Can't do it. Is it possible for a snail traveling at 2 meters per second to go 8 meters in 4 seconds? Again, the quick way I'm going to go, distance is speed times time. Is it possible? Is that reasonable? Can a snail travel 2 meters every second? So I would say, you know what? Although the math works, your numbers are bad. This is something I really try and teach kids in physics 11 and 12. I really try and get them in the habit of glancing at their answer and say, wait a minute, Mr. Dueck, you asked me to find how many watts this stove is, and I got an answer of 30 watts. That's less than a light bulb. And I know a stove uses more power than that. Or we've just finished our test on gravitation, and one of the questions I had the kids figuring out was how long it would take to orbit the moon. And I had one kid who'd forgotten to square something, got an answer way too small. He got an answer of every 3 seconds going around the moon. And I loved it because he said, Mr. Dueck, I don't know what I've done wrong, but this is totally wrong. I know it takes longer than 3 seconds to go around the moon. I loved that. And I gave him full marks for part B. He used the wrong time, but he did part B right. I gave him 4 out of 4 on the second section, and I wrote a little smiley face on the first section. Even though you did it wrong, I love the fact that you knew this is unreasonable. You didn't trust your calculator. Why is number 4 yuckier than the other ones? I'll give you a hint. Check out the units. What's wrong with this one? Okay, these units are not consistent. I'm going to change 20 minutes to hours because it's kilometers per hour. How do I change minutes to hours? I don't know. 60 minutes is how many hours? Equals what? 120 minutes is how many hours? 180 minutes is how many hours? How do you change 180 into a 3? How do you change 120 into a... This, by the way, this is my fallback, and I'm giving you a useful skill. Julie, anytime I don't know how to do a unit conversion, I'll make up easy numbers that I know the answer to, and the math has to work for the yuckier ones. How do you change a 60 into a 1, 120 into a 2, 180 into a 3? Mathematically, what could you do here? Duncan, you're dividing by 60. You know what? T is going to be 20 divided by 60. That's how many hours. 20 divided by 60. That's how many hours. And now I'm going to go distance equals speed. Oh, speed, Mr. Dueck, times time. Is it possible for him to bike 11 kilometers at 35 kilometers per hour in 20 minutes? Yeah, with a bit of time to spare. So, possible. Is that a reasonable bike speed? Can you bike that fast? You actually can if you're good, because that is school zone slow car speed. Right? School zone speed is 30 kilometers per hour, and you can, if you're ever going through a school zone, you may have seen a fast cyclist can catch you. So I'm going to say reasonable, but you got to be in shape. In fact, if we did this, I know my limits. Mr. Perugia is a serious cycler, by the way. He's an athletic freak. He windsurfs, and I think every summer, every day, he swims across Wannock Lake and then runs, or no, Bonson Lake, and then runs around it a couple of, he's an athlete. I am not. He's in good shape. Mr. Rouge's best time on a 10-kilometer run is 54 minutes. Therefore, he can complete a marathon in 3 hours, 47 minutes. This is tough. I'm going to do I'm look at 10K and then marathon. So in the 10K, why don't I like that 54? What's yucky about it? Someone said it. They're right. Minutes. Oh, how do I go from minutes to hours? Why hours? Because I noticed this has hours in it. Going to go divide by 60. So how many hours is 54 minutes? It is 0.9 of an hour. What's his speed? How do I find speed from my purple sheet? Speed is what? Distance over time. You see, now hopefully it's becoming a little repetitive. It's going to be this distance over that time. Mr. Perugia can jog at 11.11 kilometers per hour. Now you ready? I'm not actually going to do the rest. I'm going to do it in my head. Look up. So, how far could he run in 1 hour? In fact, you know what? Let's round up. 11. How far in 2 hours?
22.
How far in 3 hours? How far in 4 hours? 44. In a little less than 4 hours, could he run 42? You know what? Well, it's going to be, you know what? I think it's possible. I think it's possible. By the way, Tyra, I could have actually crunched the numbers, and I had a bunch of kids saying, what do I do with that 3 hour, 47 minutes? I think it was Joseph and your group. And I said, I showed you how to convert it, but Taylor, a cleverer way would have just been to say, you know what, that's really close to 4 hours. How far can you run in 4 hours? And if it's close to 42, a little bit more than 42, then I'm probably good. Okay. Is that reasonable? Is 11 kilometers per, well, is running a 10K in 55 minutes reasonable? Yeah. Yeah. So, I'm painfully slow. So about 3 years ago, I signed up for the Maple Ridge Hospital Run, the 5K, and I'm painfully slow. And I'm running, and then I'm running, and then I'm painfully slow. And I'm coming around the corner to the finish line, and there's a crowd there. And they start going wild. They start going crazy. And so I get my adrenaline rush. I start to kick, and I'm sprint. I mean, my face is just, and I'm running, and they're going louder and louder and louder. And about 5 meters from the finish line, the first 10K runner passed me. That's who they were cheering. I was running the 5K. I'd been lapped by the 10K guy. He ran it in 33, 34. So yes, you can run a 5K and a 10K in 55. Yeah. It was one of those, for 10 seconds, I was on cloud 9, and then when he passed me, I was just, I walked the rest of the way to the finish line. Just, Yeah. Yep. 2:30, wasn't it? Or 2:20? Okay. You guys got your stuff to work on. Certainly this time is reasonable. Is that their velocity? Well, their velocity is going to be distance over time. By the way, whose time is this? Who has the world record right now? I think he's going to run one more Olympics. I think he said he's going to run in Rio. By the way, tell me that's not the perfect last name for the fastest man on Earth. What's your last name? Bolt? Like lightning bolt? Wow. Okay. Hey, how do I change that to kilometers per hour? To go from kilometers per hour to meters per second, it's divide. To go the other way. And I don't think this is reasonable. I don't think Usain can run 50. Nope. The fastest human on the planet can run about 40 kilometers per hour. Give or take. So, possible, but unreasonable. An ostrich runs at 64 kilometers per hour. He travels 200 meters. Could he win Olympic gold if the winning time was 19.3? Why don't I like that 64? Kilometers per hour. You know what? I'm going to convert it first of all to meters per second. $17.8, I'll say. 17.77777. This is meters per second. Now, this question wants me to find how long it would take him. How do I find time? I think it's distance over velocity from the formula sheet, yes? So it's going to be 200 meters at 17.8. 200 divided by, answer button. Oh! Could he win the Olympic gold? Yeah. He could almost lap them. Right? 22 seconds and he could pass them twice. And this is reasonable. I looked it up. Ostriches can run that fast. That you wouldn't need to know. So I think it was someone. How would I know all this? I'll let you know in the question. Heinz ketchup, my favorite, flows at 500 centimeters per hour. If the bottle is 25 centimeters high, does it take 3 minutes to flow from back to front? Well, time equals distance divided by velocity. Now, this is in centimeters per hour. This is in centimeters. So, Alex, these units match. I can go 25 divided by 500. And I get 0.05 hours. Oh, I want to change that to minutes. Time. Why? How'd you figure that out? I don't deal with the decimals, Ty. I think to myself, 1 hour is how many minutes? 2 hours is how many minutes? What are you doing? timesing by 60. It has to work for the decimals too. This is an old trick I teach all my physics kids, Julia, to cut down on your memorization. You actually know a lot of this with easy numbers. It has to work with the yuckier numbers. You got to figure out what you're doing. So times by 60, and oh yeah, 3 minutes. So this is reasonable and possible. Number 9 seems very appropriate because I'm sneezing like crazy today. Sneeze travels very fast. Bart sneezes at the end of a classroom which is 12 meters long. Milhouse jumps out of the way on the other end in 0.5 seconds. Now you have to ask, first of all, can a sneeze travel 12 meters? So I would say this is unreasonable, but let's see if the math works. I'm going to convert the speed to meters per second. And I get 46.4 meters per second. How far will it travel in 1 second? 46.4 meters. Because that's what 46.4 meters. How far will it travel in about a half second? Roughly. Okay. So will Milhouse get sprayed? It's going to be well past him already if he doesn't jump. Yeah. If you want to do the math, we can. Okay, fine. I see some of you. T equals distance divided by that. 46.4 divided by, no, sorry, 12 divided by 46.4. Milhouse is going to get sprayed after 0.26 seconds. Okay, I'm not going to collect this sheet. This was to get you thinking. You have to go? Okay. Get him a school video. I'm about to jump out of an airplane.